He didn't just hit the mic on the intro, did he? What a mushroom. Oh dear. Let's try again. Hi everyone, and welcome to the Remain Indoors podcast, where we'll be looking at some science news from around the internet, having a grumble when required, which is always, and talking about the ways we're keeping ourselves entertained at home. Remain indoors. I'm your host, Richard Spanners Ready. We're going to be here on the stream for a strict time limit of 40 minutes, bringing you some interesting guests from our podcast and radio network. And when I say us, I mean me and Matt Rumpets. Good morning, Matt. Are you out of your morning slumber yet? What time is it for you there?
It is 9 a.m. And as far as you know, I'm wearing an entirely freshly laundered t-shirt that has not yet seen my body.
So I was with the kids, brought them to our local woods where there's like a fallen tree. I'd never seen it before, so maybe it was quite recent, but it's a nice sturdy fallen tree, basically a climbing frame. So I let them play with that. And I realized that I was in the same position that you are implying that you are in, which is I wasn't fully dressed. And I went, right, we're going out to the woods. I'll just grab, that t-shirt's kind of okay. Those shorts are kind of okay. And I'm going to be sweating anyway because we're on our bikes. Of course, when we got there, my boy's old school teacher, who we're now friends with, came through with her whole family. And I just realized I was there in like sweaty clothes, sweaty from cycling. I had like my mullet sticking out the back of my baseball cap. I had about 8 days growth and I just looked like I'd passed out at the side of the road and this was me just coming to. It's like, oh, hello. And then she wanted to stand there. She approached. I'm like, no, don't get any closer. Don't see the full horror. And we ended up having like a 20-minute conversation.
That's like one of those where you go out and then you realize, oh, I forgot to brush my teeth. And then you see the person who wants to have the lengthy conversation. And you're just like, hi, how are you? I'm fine. I'm fine.
Well, that's a good thing with physical distancing. They can't get close enough, can they, to smell your rancid morning breath?
Yes. So I have news. I woke up to an email.
Oh, good.
This has been a really discombobulatory week because my wife actually went back to work yesterday for the first time. And it was horrible because then I had to be the parent at home with my child for the whole day.
Wait. You parent your just about grown-up kid. How hard can it be?
When she has her final projects due for the end of year school. And she is, look, she's a good kid. She wants to do well, but she is easily distractible and has a load of electronic distraction she can avail herself of if left by herself for extended periods of time, if you get my drift.
So you have to motivate.
Plus, this was a hands-on, I had to record something and help her make a thing as well. So that was horrible. Yesterday ruined. And then I wake up this morning and I have an email about an actual gig, like playing with other musicians.
Wow.
Like in July, like a couple of weeks from now.
So you're going to be, you're going to have value in our society again.
Well, I always had a great deal of value. Thank you very much. It's just society did not quantify that value accurately, I would say.
Good. I'm glad. I'm glad to see that you'll get a chance to flex your trumpeting muscles again. It must be genuinely like almost like a sense of relief, like, this is what I do as a person.
Yeah, it is. But at the same time, it's just flat out terrifying because, of course, I will be going to a place with a crowd and other people and playing my instrument with other musicians. And I've really not done that in quite some time at this point.
I'm going to bet that you'll be still quite good at playing the trumpet. I've seen you. But I am jealous that your wife left the house for the day. That sounds nice. We are in full...
Oh, really? Things going well over at Spanners.
We are in full bicker mode. Of course, we love each other very much. We're about to have our 13th or 14th wedding anniversary on Saturday. Planning for that, we've decided to make it a family celebration rather than a couples thing. We said we'll involve the kids, we'll have a barbecue. And my daughter went, yeah, that's good, because you're always really selfish and you like put us to bed and then go to the pub or something. And so we're having a barbecue. It's our like this or something. Once a year. So that, we're making it a family celebration this year. But despite the lovingness of our marriage, we're in full on bicker mode. I'm very much in the freelance phase of throwing stuff up against the wall, especially, the new desk, the new equipment seems to be working well. Offered 2 jobs just yesterday, 2 freelance jobs, an audiobook and something in the local community, just voiceover stuff. So it all seems to be having a great effect. But I'm in a growth phase. You need to throw 10 things at the wall and get a sniff of one and keep doing that. And of course, that's quite time consuming. Her business is growing within the shed. So we're both competing for this space. And as with any healthy relationship, it's turned into bickering and point scoring and repercussions.
Yeah, so I know what this is really about. It's about iRacing, admit it.
Now, iRacing has factored into that, right? Because, like, we both complain, but in fact, it shows how situational humans are. We both complain that the other person is having all the time in the resource with the shed, and actually, you're having to stay and do stuff with the kids and not having time to do your work. And so in that dispute, we have got this now. We've got the shed log, you see, and it's just started, and we have to go in and log the time that we're in the shed so that one of us can prove the point that the other has been monopolizing all the time. Like, super healthy stuff. But as part of that, she has decided that the iRacing that we do for the official Missed Apex events officially counts as work time because that better helps her cause, helps her argument. So I'm torn. Right. Like, do I argue? No, look, a lot of that is leisure time. You can't count that as project time.
It's a trap. It's a trap.
Exactly, it's a trap. Or do I go, hooray, I've achieved the man dream of video games being classed as work by my wife?
Yeah, no, it's definitely a trap. As painful as it will be in terms of negotiating shed hours, I highly advise you, as someone who's been married at least 10 years longer, to anything that's classified as work, get some extra flexibility because it is indeed work.
It's project related, but it's jolly good fun. I mean, if that does count as part of work, because Missed Apex is work, then yeah, I'll have to take it. At the end of the day, we do need 2 sheds, as the chat room is suggesting. Thank you, Mike W. Time to become Spanner's 2 sheds ready. Sam Watley laughing at our timesheets. You can join us. Look at our Twitter account at Indoors Remain, or me at Spanners Ready, or Matt at MattPT55 to get details of when we're going live. You can join them in the live stream. And today they're joining us for some science because we're joined by Dr. Andrew Holding. Hello, Doctor.
Hello.
Andrew, I have a question for you straight away.
Yeah, go for it.
I will. I want to ask about being a scientist, right? Because my boy has suddenly got this passion for coding. A friend of ours bought him an online coding course. So he's now like in the next phase of that, and he's determined now he wants to be a professional coder. So I'm trying to think, I've been asking coders today, is it a good actual life? And with you as well, because I know my daughter's really, really into her science, as is the boy, is being a scientist a happy life?
There's many types of scientists, and that's the thing. At the moment, it's quite challenging. As someone who does a lot of lab work, and I haven't been allowed into my lab since March, that has not really helped the lab research side, because there's a load of scientists who use computers to do coding. In the biology side, we call them bioinformaticians. They've been loving it because
what was that? Bioinformaticians?
The house.
What are they called?
Bioinformaticians.
Ah, okay.
It's a word.
Is that what you are?
So I'm both. So I do lab work, and then I use bioinformatics to analyze the data I generate. So I've done some machine learning. I've used those tools to answer biological questions, and we found some really interesting results. So the answer is that there's a huge range. You can go all the way from, pipetting away in the corner of a dark room, all the way through to, you never have to leave your home and you just download data off the internet and analyze it.
Watley chips in again in the chat room. Is science a happy life? He asks of the man dressed all in black with a Death Star Zoom background. Yes, you have come a bit morbid onto our stream today, Dr. Holding.
The Death Star was in response to a comment last week, was it? Maybe fortnight. Someone said I needed to have a Death Star, so I brought one along this time. Unfortunately,
you're not an evil scientist. You would be a much better friend if you were like I'm going to create a giant laser to take over the world. But you're not. You are. I mean, on a personal level, you're not a nice person. You're not particularly pleasant, but you do have good goals in life. You're like furthering. This is good for your reputation. It's good. Don't worry. Don't put your head in your hands. This is fine. But you have lofty goals. I was paying you a compliment, but I had to insult you first because I have deep-rooted issues, but you have lofty goals. I mean, for a start, your job is to cure cancer. By the way, what happened? How close are we to that? And what happens when we do it? Do you just go, okay, pack it up, guys. We did it.
I mean, if we manage to solve the problem of how do you cure cancer,
yeah,
we would have many other questions in biology to answer. So that isn't really a concern.
So that's not the end of your career. You're not like actively stopping people from curing cancer because you'll be out of a job. Just checking. Yeah. Okay.
And there are cancers which, while not cured, there is massively better survival. So one of the leukemias has gone from 2 weeks survival now to they don't know how long you survive with it because the drugs work so well. And we just haven't, not enough people are succumbing to the disease since we invented that cure that we just don't know what the survival time is. Because if you obviously invent a drug 30 years ago and people lived 30 years, we only know that you live 30 years. We don't know when you die. So there are obviously great outcomes. There's also terrible outcomes, like pancreatic cancer is really hard to treat, mainly because we can't detect it. So if you know Steve Jobs died from pancreatic cancer, he actually did detect it early, decided to go on a health food kick instead of going for surgery.
Yeah.
And he admitted that was not the best of ideas later in his very then short remaining span of life. But we do need to do a lot of work, but most people aren't as lucky as him and don't get the early warning he did.
And that's the other thing you do. The other thing you do that makes you a good person, I think, is you try and spread, we call it skepticism, but you try and spread critical thinking. So you've spent your life, your professional career on the thankless task of trying to cure cancer. And also of trying to spread critical thinking. When you look back at nearly 40 years of life doing this, would you do it again? Does it seem like a worthwhile?
Well, here's the thing. When everyone says, would you do it again? They're kind of saying, was it good enough to do the first time? The answer is, I don't regret the choice I made. But would I do it again? No, because there's a load of other things I haven't done. And loads of stuff I've learned. I mean, 20 years ago when I was choosing what to do at university, I didn't know any of the things I knew now. I certainly didn't know how the world was going to change. A huge amount of the biology I do now didn't exist back then. We hadn't sequenced the human genome. We couldn't sequence genomes for £1,000. All these things that have come along since then. And, the whole field of bioinformatics, it existed back then, but you weren't downloading terabytes of data and number crunching it with neural networks like we are today.
So, Matt, with all that CV, all that goodness with Dr. Holding, I feel really stupid now, Matt. The two subjects we got lined up are zombie animals and sci-fi movies. I feel a bit embarrassed, Matt, but you can choose which way we go to.
Well, I was going to say I was very excited because I learned on Twitter that Mr. Dr. Holding, actually once again specialized in school in a subject that interests me. I tweeted about cross-linked polymers with sulfur compounds. And it turns out he specialized in that. And the reason this matters is because it turns out that those cross-linked sulfur polymers were what let us actually develop the rubber that we use in tires.
It feels like we're going to need a bit of a primer on what is a soft link polymer, and you've worked it back round to race tires.
Yes, it was a moonshot, and I succeeded. I'm so proud of myself.
Damn it. What's he talking about, Andrew? What's he talking about?
So Matt's talking about what his interest is how you make rubber that doesn't melt. So the early rubbers, when they got hot, because they were just like long strands of polymer, so they were just sort of next to each other. When they got hot, they melt, the tires didn't work so well. This process, he's talking about where you cross-link them, it basically means these strands are now held together. And this makes a big difference to the material. So instead of melting, it sort of burns and has a whole different type of behavior when you're running it hard on a tire. And this has huge effects in how different plastics interact and behave. One of the best experiments you can do, if you have a plastic bag and the way they're made, because when you make plastic, you pull it out to make the polymer sort of align, so the strands will align next to each other. If you actually cut a square out of it and try and pull it in one direction, it works. It's really hard to pull. If you pull it in the other direction, it just stretches immediately. And that's because if you imagine those polymers are aligned, so if you pull this way, it can be quite difficult. If you try, it comes quite easy, but if you try doing this way, they rub against each other and it's quite hard. And unsurprisingly, when they make plastic bags, they make it so the strong direction is the vertical direction. So when you put food in it, it shouldn't break out. I mean, they do because they're rubbish, but the actual what you design where you line up those filaments has a big effect on actually how the plastic responds in different directions, let alone whether it melts or chars when you go around a corner in a car.
Don't ask me to segue out of that, Matt. This is yours. This is your thing.
Oh no! I was just reading the chat room. They were very impressed at my masterful working of tyrosine. But it has implications for all sorts of materials that we use, because the different compounds, like I know sulfur was the one that led to, I think it was vulcanization is the technical term. But my understanding is that with modern tires, they use a whole host of different compounds for cross-linking and to achieve different performance characteristics and envelopes. And I would assume the same is true for plastics in any other petroleum-based product that we currently use.
So the things I was actually cross-linking was, if you look in the cell, it's full of protein. You've probably heard about the thing that people talk about in meat. Proteins are interesting because they're actually a polymer. So that means they're long strands. And what's different about protein than, say, a plastic is every part of that polymer, every bit, sort of monomer, as we call it, that makes it up, it can be different. And that's defined actually through DNA and all the genetic structure. So that's quite cool. And depending on the order, depends how they wrap up into a ball. And they can make all sorts of fancy shapes. You can get also long tube ones. You can get ones that sit through the cell membrane. But cross-linking is a key part of that. And one of the amino acids, one of these monomer, the building blocks, actually has sulfur. And they readily form these sulfur cross-links. So what I was doing was I was actually making extra ones by putting on chemicals which we knew would cause these cross-links to occur. And then from that, finding them using a mass spectrometer and saying, oh, these bits of the protein are close or far away. And we use that to actually determine how these polymers which fold up in DNA replication in bacteria, how they dealt with DNA errors, because we could find which bits of that little molecular machinery is near each other. So cross-linking goes all the way, rubber and tires, hugely important because it completely changed how you made tires, but also we can look at them in life and see how things are interacting and working together. So hugely important across everything. And, it seems such a trivial thing, a little bond between two parts of a long chain of molecules.
Fascinating, Dr. Holding. Thank you for that. I just want to call out Matt Trumpets nodding along there at the end. Liar. You were not following that along intelligently. It's a bluff. You panicked because he's gone down a route you couldn't follow, or no human could.
Well, actually, I was going to ask, given that your studies were in the folding of proteins and identifying where things wound up, I begin to see that there's a possible crossover, because isn't one of the challenges in treating cancer finding a way to attach specific drugs to specific cells? And in particular, I'm thinking of how enzymes react. The shape of the protein matters in terms of how the cell, whether or not the cell will interact with it and or take it into its internal machinery.
I swear this will get fun. I swear. Keep listening. Keep with us. Stick with it.
So the idea we had when we were looking at E. coli, how it reproduces DNA, because obviously it needs to do that to divide. And dividing bacteria is bad because you get more bacteria and that makes you more ill. Bacteria don't have the same machinery as we do. It's similar, but it's, we've evolved a bit since we were bacteria.
Right.
And what we were hoping was exactly that. If we could work out the structure and we could find out what was different, then maybe we can make drugs that would go into those sort of shapes and those holes in the machinery and jam it. So basically just sticking a wedge in the gear, but finding a gear that is only in bacteria, not a gear that's in humans. Because if you make a drug that kills bacteria but also kills people, and we have plenty of them, bleach is a great one, you can't inject it into people. Don't inject bleach. I know that's been proposed recently, but it's bad because it isn't selective. And what the key thing is finding those things that will go into a cell and only affect the cell you want to target. Now, cancer is really a step harder because a cancer cell is a human cell. So the cancers we've done really well at are ones where they have mutations which are very specific to the cancer, and therefore they have something unique you can jam that cog. The ones we find really difficult, the ones that still very much seem like a normal cell. And then you're trying to work out, well, what makes this cancer cancer? And can we find something we can sort of get in there and attack? And, when you talk about classic chemotherapies, they are, well known for the side effects. They don't make you feel well. And they really are reliant on the fact that cancer cells are growing, where a lot of your body after a certain age doesn't grow as much. And that means you just try and use the fact that they're growing a bit more than the other bits, that if you just put something toxic for growing cells, that hopefully you'll kill the cancer tumor a bit more. And it does work. But certainly, the more targeted therapies are much more pleasant for the patient. They have fewer side effects and better outcomes. And that's really where we want to be, is finding those basically really special pegs to shove in the cog to shut down a cancer.
Do you know where I want to be, Dr. Holding?
Where?
Talking about movies?
Transported to another world through the form of movie magic. Yes, that's right. I promised you 2 weeks ago that we would talk about some of the sci-fi in movies, and if I'm anything else, it is a fulfiller of promises of content. I have never ever promised like a whole show on two-stroke engines and then never ever delivered it. I would never do that to you. Just remember, in the divorce, if we ever divorce, a podcast divorce, remember who lied to you about two-stroke engines. That's all I'm saying, Matt. I'm a promise keeper. That's all. That's all.
Talk to Kyle. That's all I got to say. My notes are ready to go.
Ah, I see. Diverting. Okay. Guilt transference, I think that's called.
Throwing Kyle under the bus on this one.
That's what my therapist calls that. Guilt transference. Dr. Holding, movies. Let's start with Interstellar, because that was your suggestion. And it's been a while since I've seen Interstellar, but it's basically Matthew McConaughey. He's like, oh, the planet is dying. You need to go on a spaceship to find us somewhere else and go through wormholes. And he's like, all right. Let's go through the wormholes. And I don't think this is anything spoilerific. Then his daughter is on Earth trying to find a cure for the Earth or something or other. But the point is they end up being separated across time and space. And somehow they all link back together to find a solution. Or not. We don't know. Maybe they don't find a solution. They do. The most interesting part of that for me, and I don't know if this is the thing that you wanted to bring up, was the time dilation and how they got separated through space and time.
Yeah, so in the movie, one of the big things is they have this wormhole that takes them to a black hole with planets orbiting it. And the reason why it's kind of interesting is one of the things in this movie in terms of time dilation and time in general is they kind of accept it's something they're going to have to deal with because space is big and it takes a long time to go anywhere. And if you want to go anywhere quickly, there's usually time dilation. But they also have to do that classic thing that you'll find in nearly all sci-fi is I want to get from A to B faster than the speed of light.
Yeah.
So if you do a story, you can do good stories in space. Martian does it very well. But if you want to go somewhere a bit more different, you're then going to have to somehow deal with long distances. So they have a wormhole appeared. I think they genuinely, it's a plot element. They don't even explain where it comes from.
No, they just exist. In this universe, they just exist. So
it just turned up.
Changing one fundamental law of physics or creating something like a wormhole as a plot device, I think as long as they don't do too much, and as long as they establish early and they go, hello, movie watcher, by the way, there's a thing called wormholes and they help you very easily. And there's no harm to humans or anything and it's all fine. They just exist. Go. And it's consistent. Then you can kind of forgive that. They're not going full Star Wars with Death Troopers, whatever they're called, Death Troopers manually pushing a gun on the outside of a Death Star that randomly holds their gravity in a certain direction. No, it's not like that. That's garbage. But when it comes to just saying, okay, we've got a wormhole that's going to let us go to another solar system, I think we can forgive that. The film wouldn't have worked without it.
I like the fact you pick on Star Wars for the troopers, not for the fact it has space magic. But anyway.
Look, the troopers are on that. They're on a spaceship and the gun thing isn't automated, which you would have if you had that level of technology. They just stood there. And if you're on a globe thing, which way's the gravity? It seemed like gravity was from the top of the ball to the bottom of the ball. Not even from the top to the middle. Whatever. Star Trek.
Well, to painfully agree with you.
Okay.
Sci-fi, it's best when they set up a set of rules and they work in that rules and explore it. And that's doesn't actually just apply to sci-fi. I think it applies to any sort of speculative fiction. So it could be a political drama where they say, right, the only thing we're going to change is this, and we see what happens.
Yeah.
And I think it's a really good way to explore ideas and concepts and what Interstellar brings to the audience. And it does it in a very sort of big cinema way. And that was the point of it, is this idea that they're going to a black hole, and around a black hole, time behaves differently because of all the forces and effects that happen onto the crew of the ship.
Yeah.
So they go away for this mission and they know that they have a very limited time to get back because time for them is going faster than it is basically for people back home.
Yeah. So that's right. So if they got too close.
In fact, this is the classic mistake I make, is the people get home are getting older and they're staying still. So actually time's going slower.
But less time is passing for the people who are near this big gravity well. So they go to a planet. And it's like a huge planet. The gravity's because it's a planet near to this massive gravity. So essentially, this mission, they know that every like 10 minutes they're losing like a year or something, and then something goes wrong and they end up losing like a bunch of years. And I just thought that whole thing was fascinating, because there was real peril to going down onto that planet, and it changed the whole course of the film using this concept of science and this concept of how they would be affected by time. And especially like they send one person to the planet, and then there's a small delay for the second person going, and for the first person it's been tons and tons of years, all that kind of stuff. I think it works really well in the film. There was a lot that annoyed me about it, but that was interesting science.
Well, one of the ones is when they land on the ocean planet, and they land and they realize that because of the time dilation, they've actually only landed there shortly after the first person, but they can't find anything of them. And what they discover is actually very, very rapidly, they're at a huge risk of being wiped out themselves. But they sort of turned up expecting the person's been there for long enough to actually establish themselves, but where in fact they were there for about 5 minutes before they all got destroyed. And it's been only about another 10 minutes in their time frame before they landed behind them. So nothing's happened there. And they realize how much time they're wasting.
So what's the science here, though, properly? Because what was it the actual mass of the object they were near? If we find a real black hole and go close to it, does the relative time for me slow down? So can I time travel to the future by going near a black hole, letting reality behind me go 1,000 years, and then come back and I'm 1,000 years in the future?
So the effect is actually acceleration, and we don't normally think of gravity as an acceleration, because you normally think about that gravity is the thing that hurts when you hit the ground. That's just because you're a human being and that's more relevant to you. But that downwards force, if you jump out of a plane, obviously makes you accelerate. And this all fits in with Einstein's theory of relativity. And therefore, what happens when you're near a black hole, even if you're orbiting a black hole, that huge potential well of gravity pulling things towards the black hole, that is affecting time. And this is usually quite a small effect. But in that movie, what we're showing is a situation where it's really, really big effect because there's a really high gravitational well. So it all fits back to Einstein's theories of relativity, which are not exactly the easiest science to understand, but get some really quirky results that I think are interesting. And if you were to try and fly from one star to another, so if we're trying to go to our nearest neighboring star, we'd have the same problem, because if we try and accelerate up to the speed of light, we go through these huge accelerations and travel at these high velocities, we'd also see time dilation occur. And that time dilation would mean we could fly our ship and feel like we get there really quickly. But because the universe sort of fights back, you end up with everywhere else would sort of accelerate through time quicker. And when you get there, the whole universe would have moved on, even if you only took a week to get there.
On a related note, Beth in the chat room would like to know about the Stargate series. She says the writers made some shows about this. Do you know how accurate their science was? And actually, my wife, trolling the internet this morning, read me a story that using quantum computers, physicists have actually reversed time on the electron level, using some complicated thing that I haven't actually read the article about yet. So sorry for bringing that up with virtually no context.
Time travel's real.
On an electron level.
Finally.
Yeah, but my last question is, if we were to try and use something like a gravity well to travel to the future in the manner Spanners suggest, isn't there a point at which the tidal forces of the gravity well would pose a distinctive biological hazard to whatever craft we sent out?
Yeah, so tidal forces are a real challenge. And we're quite used to them, because the tidal forces are what cause the tides on this planet. So you are aware of them, even if you wouldn't think about them being linked to black holes. And what this is as the moon goes around the Earth, some of the water is pulled towards the moon, and some of it actually ends up, it's not being pulled away, but you get this effect where you get a bulge on the other side as it's under less gravity than the side nearer the moon. And that's basically that gradient of gravity. Things close to the moon are pulled more. So the water on one side is pulled more, the bit in the middle, the Earth is pulled a bit less, and the bit on the other side is pulled even less. When you get to a black hole, that's because the gradient of that gravity well is much, much steeper, because the black hole is very, very small but very, very heavy. Those effects those tidal forces pulling the water either side of the planet get bigger, to the point that if you're a person standing very near a black hole, your head will be pulled away from your legs quite rapidly, because that tidal force is trying to stretch you. So that's clearly bad. Of course, your sort of question is asking, will we have this problem? There's other ways which are easier if you want to travel forward, mainly because if you're going to go and find a black hole, you've got to get there. So you might as well just fly very, very quickly to the next star, slingshot around the star and head back again. It's going to take you a long time. It's going to take a huge amount of energy to get those speeds. That's the other problem. But if you can, got the money for it, you can do it. The other challenge, of course, is it's going to, unless you can go really, really, really quick, it's still going to take a long time. And really, really, really quick requires huge amounts of energy to do.
Let me trivialize the science you've been so expertly expressing with this glib point. Well, it works for Infinite Monkey Cage. Come on. Right, so instead of cryogenically freezing people at the point of death, in the future, we can just launch sick people towards a black hole or very, very fast and be like, set them to come back in 200 years. And they're like, as they're flying by, have you got a cure for cancer yet? No. Well, and then that's it. And then they go off and do another lap. There we go. Has Dr. Holding solved it yet? No, robot Dr. Holding still working on it.
It's cheaper to freeze people, a lot cheaper to freeze people.
Okay.
I mean, at the moment we kill people when we freeze them, but presumably we can get better at that, even though it's actually quite a hard thing to do.
Let's roll on.
We're good at freezing cells.
Let's roll on a little bit because we've got we only got one other one I really want to get to because we were talking about the wormholes and the kind of cheat, if you like, of it's a wormhole. That's how you get to another star system. Was the movie Passengers? I think it's called Passengers with Chris Pratt and Jennifer Lawrence. Was that any better at depicting the problem of the interstellar time? So they were taking a longer journey, all being put in a deep sleep, being sent to another colony.
Yeah, so Passengers had this idea of a hibernation pod. As I say, we can't do that yet. So if you the idea was you put someone in these, they went to sleep. But of course, it's as we said, it's very hard to freeze people, and you still age when you're asleep. So if you put someone into a coma for 40 years, they still they get 40 years older. Also,
that's how they get you.
If you do it now, you'd also end up with massive muscle atrophy and all other sorts of things. And this is actually a real challenge because, you might medically induce a coma. And even if it's a few weeks, the person actually loses a huge amount of muscle from not doing it. So ignoring that because maybe they came up with a machine that freezes you and does it. And you say, you're allowed to make the odd.
What's the future?
And it is credible. The idea is not unreasonable. You build a ship that you just go, well, we will take the extra time to get there.
Yeah. So, Matt?
Yeah. Okay. So let's talk about freezing things. In my vaguely considered general knowledge, I know there are certain single-celled organisms that can be frozen and unfrozen. Are there more complex organisms that can survive? I mean, I think water bears, maybe, or whatever they're called. Do they lose? Are they analogous enough to like human tissue? Is there anything analogous enough to human tissue that if it were like properly frozen, as opposed to just say put into a coma, that you could say that, we can keep it for an indefinite period of time, and then when it's revived, it has not atrophied in the same way that we do when we're just, say, in a medically induced or just naturally induced coma?
So the issue really here is what happens when you freeze things and the cells rupture. So yeah, tardigrades, water bears, you can basically put in space and some of them will survive. And they are still quite simple. And they have a different cellular makeup, and they have things that make them a bit more resilient. There are fish actually who live in the Arctic who are full of antifreeze proteins effectively. And I wouldn't be surprised if some of those, if you froze in ice, would get out okay on a reasonable number, because they're basically designed to live in -20, -40 conditions. They're really well adapted creatures. You and I don't have any of that. That said, we do this in the cancer lab all the time. If we take some cells and put them in the right solvents and freeze them down in liquid nitrogen, we can keep human cells in the lab. The problem is we lose a good chunk of them. So some of the experimental systems, when we're trying to model stuff for cancer, we'll grow a cancer tumor in the lab on plastic, and it'll be a petri dish with human cells, and we can freeze them down and thaw them anytime. And this is fairly famous because of the book about the HeLa cells and Henrietta Lacks. So you can read a lot about the history and actually some of the negative ethics to the whole issue, because when it's originally started, there weren't any ethics, and it was just cells from a patient who didn't consent. So we know we can freeze human cells. The problem is you basically need most of the neurons in your brain. And if you start killing a load of neurons in your brain and you lose that structure, because remember, nothing I've talked about here is about maintaining structure. You are destroying a huge amount of information you can't get back. But, people are actively researching this, usually rich people who want to be immortal rather than the main scientific field. But there are thoughts and ideas behind how you do this. And then in the more scientific end of it, you have people looking at how do you keep patients alive in critical conditions for longer. So we know that if you put a trauma victim to a very low temperature, you can maintain them for longer. And there's all these kind of things, slow the metabolism down to give you a bit more time. I mean, you transfer organs on ice around the country when you're doing organ donors. So the answer is, can we freeze a whole person and bring them back a few hundred years later? I don't know the answer. Do we have bits and pieces going on in the scientific world heading towards that? Yes. Are there slightly more people taking the higher risk, get there quick strategy? Yes, rich people who want to try and do it before they die. So it really depends if you're doing it for yourself or are you doing it for medical good. And the people doing it for medical good are more trying to do that incremental and actually get it right.
Well, the thing is, there's not going to be a push to cure death, really, ultimately, whilst people are, predominantly religious. Because if you prolong death and cure death, you're just keeping yourself away from, super duper heaven or whatever your version is, Valhalla. So, there's not really that. Is there an ultimate desire? I remember thinking as a kid, we've got all these really clever people. We should just put them on the island and their only job should be life extension and curing all the diseases. And we will give them all the stuff. They can have any video games they want. They can have all the sweets. They can have all the best stuff. But their job is just to work on not dying so quickly. Why can't we do that? Why can't we have a non-death island? Isle of Wight. Perfect.
But we have extended life expectancy more and more and more. And that's why we see other things going wrong. And the trouble is, some of the ways you extend life expectancy is just changing what people eat, what people drink.
All right. I feel attacked. All right.
Well, no, but it is. And then this brings us to a really important point, is you also want quality of life. So if we end up living to 105 or 130 on average, but we have the health of the physical abilities of a current 105, 120-year-old, you are really infirm. And that actually, when we talk about health and prolonging life, there are things we want to do more than just keep you alive. And so there's a lot of research in a lot of directions. And one of the things would be to slow down aging. One of the obvious ones, which gets, is heavily researched, is Alzheimer's and dementia. Because if your brain's not functioning as the way it did when you were in your 30s or your 40s, if you ever dealt with someone with dementia, you realize that it's a horrible thing to happen. And no one wants to live out the last 50 years of their life with dementia.
You left out your 50s with regards to brain function there, my friend.
I didn't want to write off too many of our audience too soon. But the reality is that we all know, depending on experience, there are certain things that start failing at certain ages. But maybe some of these things are easier to replace than others. We can replace hips, we can replace knees. If we can make those last for longer, even better. But if you start replacing things like hips, then other things start breaking, like the bone around the hip, because you put some titanium near some old bone, and then if the person falls over, the bone still has osteoporosis, still shatters. So I think when we'll be at the point where we can replace every organ in the body, are we getting there? Yeah.
I only need my brain. I'm more than happy being plumbed into a robot body, and I don't think that feels that far away, where we can control a robot arm. If you connect something to your brain, hasn't your brain got the capacity that if it's somehow got 4 extra arms, it would just learn to use them? Matt, I've heard that.
Not only have I heard it, I have seen the pictures. They've developed a third arm. I believe I saw this from Japan, and they just attach it to a chair. So when you sit down, you have this third arm, you put on your little cap, and you can control the third arm while you're doing things with your 2 arms. And they have video of people doing this. This is a thing that has already happened. You could buy a third arm for your chair, and it's just fearsome.
I could do with an extra arm. What is this on? Is this on Prime? Is it on Amazon Prime? I've got a Prime subscription. But Dr. Holding, I think the point is, we can eventually plumb things into our brain. It's real. It's a thing. So robot body, it depends, how palatable is that? I personally have no objection to swapping out this before. I'll swap that for an Android body. I'll do that, Dr. Holding. I don't mind. And then I can have 1,000 years, or will my brain just rot away?
I mean, the question is the brain, because, the idea of a brain attaching something that picks up some neural impulses seems sense. And you can obviously there are people who are born with extra limbs, people who are born with an extra thumb or extra finger, and it works. And the brain does have this massive ability to adapt and learn how to use these things. So you can see where we're heading. But if you take a brain out of a human body, where's the blood supply going to come from? How are you going to oxygenate it? Where's the immune system going to come from?
Excuse me, Dr. Holding, you're the scientist. That is your problem. I pose the questions, you solve it. So supply some blood with a machine, a blood supply machine. How hard can it be? It's a floppy bit of flesh that goes in and out. How hard? Come on, science.
Because you don't want it to clot the blood, and then you have a stroke, and then you're dead.
See, Matt's pointing out, we do have machines already.
Heart-lung machines. They use them when they bypass the heart. So,
but they are complicated because blood clotting is a real challenge, and this is the thing. And if you have no bone marrow, you're not producing new blood.
All right. So I'm hearing.
So you're now going to be a blood transfusion. So the answer is probably the idea of taking your brain out and just stick it into a box and having the whole of the body. That bodies are actually quite good already.
You're ruining it.
The other option, of course, is you could start cloning organs. And then if you can grow someone a new liver, a new heart, so they have a heart of a 20-year-old, that sounds cool. But all of these things then bring up other challenges. And if we're going to talk about slightly crazy sci-fi movie ideas, there is, of course, the idea of you download your brain into the Matrix, whatever it is.
No, I don't like that.
And again, there's a massive number of people in Silicon Valley who think this is the way forward.
I don't like it because there's no continuity of conscience. Therefore, you're just making a copy of yourself. Matt, I'm sure I've ranted about this before. And normally it's Spanners. This is a Formula One show. Why are you ranting about continuity of consciousness? Dude, you're on the gardening show. But it's something on my mind. No, I want no interruption to my consciousness. It must remain in my brain or slowly transfer to a robot brain, Matt, or I'm out.
But we in theory do that.
I was trying to throw to Matt just for a second. Has he switched off?
I mean, the discontinuity happens every night when you go to sleep. And your brain changes overnight, and when you wake up, you're a different person. So I fail to see the difference on a personal level.
Dr. Holden, please tell him why that's wrong and why he's ruining it. That doesn't make sense.
No, discontinuities happen, and
I don't switch off at night.
But the weird thing is, and I can't get my head around this, and I think is you don't usually end up with a copy of yourself the next morning.
Yeah.
And if you make the ability to copy yourself, that is slightly odd. But if you made a machine which went into your brain and replaced each neuron as it died, and that's just something that happens as you get older with a computerized alternative, and then it did it one neuron at a time. Most people will say, well, that's just fixing the damage and I'll be happy with that. If you made it so that it went through and started killing the neurons and kept growing, a little bit creepy, but most people still accept that if you said it took 2 years to do this, you still would have this gentle transition you're talking about. Now, what happens if it scans it, destroys it, and then rebuilds it 5 seconds later? What's the difference between that and the previous form? And the answer is it's very hard to argue there's a difference, but it creeps us out. If you take it a step further, what happens if I scan it, build the new one, then destroy the old one after I've built the new one?
Yeah, I'm out.
And this continuum of examples, and I agree, there is a immediate going, I don't like that I'm not comfortable with that. And this is where we get into ethics, and these are hugely important things to discuss before someone starts doing this, which isn't going to happen anytime soon. But it isn't as clear cut as going, we can't do this.
Right. So Beth in the chat room asked, you were talking about cloning organs and regrowing them. She says, what if someone has, say, liver cancer and then gets a new liver grown from their cells? Won't they just get the same cancer again?
So it's a good question, and especially good because the liver is unusual. In fact, the liver is a really basic organ in terms of its structure. So you can actually cut away half the liver and it will regrow. The reason why it doesn't regrow in people with cancer or people who have got damage to the liver is because it's scarred. So if you drink too much alcohol, you scar your liver and it won't regrow. Will you get cancer again? It depends why you got cancer. So if you had a genetic defect in your genome that led to cancer, and it's hereditary, you may get the same cancer again. Remember, it's all statistical. If you got that cancer because you injected a cancer-informing compound into your liver, which could be literally injecting because you decide to do something stupid, or you have worked in an industry where your employer wasn't taking care of you, which has happened many times in history and still probably happens, then you've removed the thing that caused cancer. So the liver could be just put back in there and you would be happy. Now, of course, liver transplants aren't a trivial operation, but it would be fantastic if we can make a liver which we can then slot back into someone's body, because for any of the diseases which give you liver cancer, it could fix it. Another example, though, would be someone who has hepatitis, a virus that damages the liver. That will probably, unfortunately, still be in the body. So you'll put the new liver in, they'll probably start damaging their liver again from hepatitis. But of course, if we do this well, and you can just change the liver over every 5 years, every 10 years, that's a lot better than having liver failure, which is horrific. So it will just be like servicing your car, which may be a lot of work. Depends how good the medicine gets.
It would be like changing a filter, almost, literally.
Given what a liver is, yeah.
Yeah. Okay. Yeah. Well, that's, you know, I was very hesitant before I said that. I was like, hang on, liver's like and the thing is, liver, it's all like a lump of the same stuff, isn't it? It's not like a working machine where there's like, oh, there's parts of the liver. It's just like, it's like a lump. It's all lumps of the same thing, right? This is my medical knowledge.
Liver's pretty, as tissue goes, it's about as undifferentiated as you can get.
Right.
It does obviously have blood flow and stuff for it, and this is one of the issues with doing any operation on the liver. It's got so much blood flow. If you try doing surgery on it and you basically cut one of those arteries, you kill the person because they just bleed to death. So, don't want to trivialize the medicine that goes into a liver transplant. It's incredibly complicated, but it is done, and that medical technology exists.
It's no intestines, though, is it? From a complexity point of view, that's all I'm saying. I took a punt. I've got no idea. I don't know what I'm saying. I think we should stop. I think we should talk about.
You should stop.
Let's go. Okay.
I'll email you some photos of intestines.
No, I'm good. No,
you're good.
That's fine. It's fine if you don't.
I have some pathologist friends who happily share these images with me.
I don't want to waste any of your time, Dr. Holding. That's not true. I routinely waste your time on trivial topics, and I want to end the show with what could be quick. It could be drawn out. I'm not sure. But I found, looking around the science news. Oh, this counts as news. Oh no, I've lost my labels. Which one do you think?
We're going to ruin the show if you actually talk about news, though.
No, hang on. I will. No. Yes, there it is. Haha, took a punt. Big dirty news. Oh, there it is. Look. There's my little label thing that goes over my buttons with news on it, but I couldn't find it. I'm going to blame the wife. She moved it. But I got the right button. I had to guess. Could have been a disaster if I'd have just gone,
Whose fault is it?
Well, now we know whose it is. It's your wife, because she moved it.
It's her fault. She's always in my shed. She's moving it. It's my stuff. She's ruining all my stuff.
Buy another shed.
I could do. Well,
you can get those garden offices, because yours is very much a shed. Some of those garden offices have 2 rooms even. So
they do. We don't have the biggest garden in the world, and this really was a labour of love. This shed, don't talk about it a great deal, the construction of it, but it was just a 3 metre by 3 metre shed that the guy before was using as a rabbit hutch. So we pulled the floors out. It was a floating deck. Replaced it with proper like insulation and like separation of sound. So a lot of things with acoustics, you can hear like bass from like next door's house, even though you're separated in the garden. So it's all like mechanically separated. There's mechanical separation all throughout the walls, like a real labour of love. And the thought of doing that again makes me never want to do any audio podcasting or radio. I would rather, when this shed dies, so does my career. So I'm certainly not building another one. Right. News. I looked at the news thing, and it was at sciencenewsforstudents.org. Have you heard of this site, or have I stumbled on a spammy fake site? Do you know it?
I mean, I don't know the site by name.
Well, I sent you the show notes, but whatever. You're a busy man. It's fun. Zombie animals, Andrew, and the one that leaped out at me on the page was because I've read this article now. Science News for Students /article/zombies-r-real. There you go. That's an easy way to share a link. Right. Well, the one that jumped out at me and made me think maybe we're zombie animals too is the horsehair worm needs to emerge in water. So to make this happen, it forces the insect host that it's a parasite of to leap into a lake or swimming pool, often drowning the host, so it can be born in water. And this is a worm, but we'll also talk about some funguses that are actually getting into the brains of other creatures to make them do stuff. Like, first question, are we sure nothing is doing that to us right now?
No.
Oh, man.
It's a little bit more subtle if it is, but we're not entirely sure, no. When we talked about evolution last time on here, we said that one of the original things against evolution was it's horrific and brutal.
Yeah.
All of this stuff you're about to look into is horrific and brutal. So you got the zombie stuff you talked about. Did you come across I think it's the emerald cockroach?
Is this the one where it gets? Sorry, just drinking a drink there. Is this the one where a wasp darts into its brain, into this cockroach, and then makes it placidly walk with a larvae ingested in it, walk into a rock thing, and then the wasp like locks it in, and it's the dinner for the wasp larvae, and the cockroach is just like, yeah, this is fine, I guess.
Yeah, so sorry, it's the emerald wasp, and it infects a cockroach.
Right.
But what's amazing is it paralyzes the poor cockroach, but it then like makes it walk by using a stinger to do brain surgery to make the thing back into a place where it can't move, and then it lays its eggs inside it, and the eggs eat it from the inside out whilst it's paralyzed and can't move. It's like Alien.
It's like the pickle episode of Rick and Morty. Have you seen that? No.
I've seen much Rick and Morty, but I can't remember which pickle episode.
Oh no, then you haven't seen it. If you can't remember the pickle episode of Rick and
There's
Morty,
a few pickle episodes, aren't there?
No, Pickle Rick. Go and search Pickle Rick.
I do remember
that's
Pickle
your
Rick.
that's your
I can't
homework.
remember.
It's amazing. But basically, yeah, he is a pickle and all he can move is his tongue. So he like gets a cockroach and manages to stab into its brain and then manipulate the cockroach's feet to like crawl, and then before long he's got like all loads of robot limbs plugged into his pickle brain. No, not robot limbs.
That sounds like Rick and Morty, and that is, a smidge different, but yeah.
So like in this case, I mean, we'll stick before we go to the fungus. Stick with this. The wasp is, or like a worm in the case of the horsehair worm, has evolved to go into the brain and knows which bits of the brain to touch to make a leg move. So it's just going up, left, right, just like a remote control. That's horrifying.
So, and you mentioned fungus, which is the cordyceps fungus, which is also the basis of the computer game The Last of Us on PlayStation, I think.
Yes.
They have cordyceps zombies, human ones though, where in reality it's insects. Every fungus is specific pretty much to the insect it infects. And what they do is, if it gets into an ant hive, is it gets into the brain of one of them. And then that then causes it to sort of walk up to the top of the mound the ants are living in. It bursts out its head, a bit more slowly. It's a fungus, not an alien. And then it sprays spores over the whole of the colony. And this kills them all. And actually, ants have learned to spot this happening. If they see an ant doing this, they will push it out and try and get it away from their colony as quickly as possible. So it's a back and forth. To get that level of ability to make the organism do what it wants, it's had to evolve specifically for the insect it infects.
So looking at some other examples here, where the animal is forced into kind of suicidal tendencies, I'm not going to, shall I try and say this? Toxoplasma gondii. I'm sure you'll be familiar.
Toxoplasmosis gondii, yeah, or something like that, yeah.
Hate and
So
admire.
this is an interesting one.
Yeah, okay.
This is an interesting one. So this is the one where rats get attracted to cat urine, isn't it?
Yeah, so it makes them cat
Which
friendly.
is not a clever thing for a rat. So rats usually run away from cats. It's a life skill, and suddenly this means they don't have fear anymore. And they need to reproduce in cats, so they make rats run towards cats. But what is fascinating, and you were asking, is it in humans? There was a study, and I don't know if it's been properly followed up on, that showed that if you look at the infection rate in motorcycle accidents, motorcyclists who die in high-risk accidents are much more likely to have an infection of this parasite.
What? What's it called? This one?
Toxoplasmosis. So it's likely that even though it's not making them go towards cats and roll around underneath a cat, it could be making them to have higher risk-taking behavior. And as I said, I saw one study, and I don't know if it's actually been followed up fully rigorously yet, but you would expect that if it's able to affect a mammal brain, because remember, we use rats as models of humans all the time.
Yeah,
there's a good chance that this thing can actually affect human behavior.
So can I get tested? Can I get tested to see if I have plasmogondii?
Toxoplasmosis, yeah.
Okay. So, and I need details here, Dr. Holding. How do I do that? Do I send off? Does it come in 3 easy payments?
To be honest, I never checked because, I'd rather not know.
Tom Wheatley in the chat room points out that makes so much sense because we are ruled over by cats.
The motorcycle thing, there's got to be more to that. It can't just be that like we get this cat fungus or this cat thing and that makes us
not fungus, but yeah.
So what does it do? Like make us less risk averse or something?
Yeah.
So like
that's the hypothesis. Yeah. That's the hypothesis. And as I say, last time I looked into this was a few years ago when I was doing a show on talking to the public about zombies. And it was striking bit of data, but it was one study that somebody had done, and I don't know why it hasn't been followed up. It might be just because there isn't a huge concern about something that doesn't seem to be destroying the world.
Okay, so in line with this, I found another example, which was a zombie fish. And if this fish was infected with stuff, these bits that things that go directly onto their brain, they were more likely to just act oddly. They would be normal, they would do all their normal social things, but they would be more likely to dart towards the surface, twist their body, do things that attract birds, because this bug needs to get eaten to complete its life cycle. And if you're telling me there's something similar with humans, I do remember, like in the military, I would often get mocked because I was quite risk averse, really, for a military person. And I would try and say to the lads, I was like, lads, like death only has to win once. We're trying to win every single day here. And it was with things like just as simple as like working with a suspended load. And it'd be like, just never go underneath it. And they'd be like, yeah, but it's got this, it's got that. Yeah, but only 3 things have got to go wrong now for you to die. You do that 100 times, the chances of 3 things, etc., etc. And it just felt like there were some people who just did not have the same just fear of risk that I did. I was scared all the time. It
isn't just toxoplasmosis. So let's just be clear.
No. We've found the solution. Don't muddy the waters.
Come across the fact that some people don't have the ability to have fear of heights?
No.
And this is hereditary. So this is a New York story, actually.
You're talking about the Mohawk Indians, right?
Well, that's a classic example, yeah.
Yeah.
Tell me. I've never heard of this.
I mean, I'll let Matt explain it because
he
knows more about New York history than I do.
Well, it is a thing that amongst the iron workers, there was a tribe, I believe, of Mohawk, lived up in Canada, and they would travel down and stay in New York, and they would work on the iron for all of the skyscrapers that were built in the 30s, 40s, 50s, 60s. And they were entirely unaffected by and would generally eschew using any safety measures whatsoever. It just simply wouldn't bother them to walk on a 1x3 steel girder, 600-700 feet above the ground. And that's how they, as a tribe, that's how they made money for themselves to exist in a modern society. That's what I know about them. And that there was a bar in one of my old Brooklyn neighborhoods that they used to frequent, which is really how I came to know about them at all. But it makes sense to posit there might be a genetic thing, but I didn't know that anyone had actually studied it.
I mean, it's one of the classic examples that's given forward. Whether someone's actually found the gene related to it or whether it's a lot of individual genes working together, that's a whole different topic. But the fact that there seems to be a hereditary trait within people means it's most likely something about how the genetic background, because if you think about it, it's not like these people had a history of climbing up skyscrapers as children.
Wait a minute, I've got it. Hang on, right. Listening to something on the SGU. When I say I got it, I don't mean I've solved it. But could it be not genetic, but to do with where they evolved? So SGU was talking about...
They evolved in exactly the same place. They're human. We all evolved in the same place, pretty much.
Okay, but you can get more local than that. Okay, the SGU example was sickle cell, and lots of people associate that with being a black condition, where people who are black are more likely to have sickle cell. And then one of their guests posited that it was more to do with where they had spent, ancestrally, had spent time where sickle cell gave you some kind of immunity to malaria. Therefore, people in that area would have sickle cell. So could it be not so much genetic, but to do where that tribe and stuff had spent there thousands of years?
I mean, it could be, or it could be simple. They didn't need a fear of heights. So it's not like they grew this as a useful ability. It's just they lost an ability that they never needed because they weren't in trees anymore. Because presumably not falling off things is useful if you're living in a massive jungle. But we don't know. And that's the thing about evolution. It's very hard to say what happens. But there are other... we did all evolve from the same species, and we are very similar, but there are obviously subpopulations of genetic differences that are very particular. And that's why we also see in my field, certain ethnicities being more likely to get one type of cancer than another. There's certain very small groups of people who have massively high risk of breast cancer. And it's just because they have a damage in one of the genes. And because they've been a very isolated population for a very long time, that gene has managed to become quite persistent in that population. But there are two ways to resolve it. One is they start mingling with other people, which is great. Or because sometimes there's cultural reasons they don't want to, then we now, we go, right, well, we know we need to screen you more often for this, which is saying what we do with sickle cell. If you have a child and they're at risk of one of these genetic diseases, we should now screen it very early on. And actually in the UK, we're quite good, from my experience when I had two kids, they even look at me and go, well, I know you and your wife are white, but we still want, are you actually white? Or is there any chance that that you've just got pale skin and we're not just looking at you and making assumptions? And that's obviously something we have to be really careful on, because these genetics end up in places you don't expect them now when people have such a diversity of backgrounds.
You've made a good case, but I still think it's the fungi. I think it is the Ploxogogon thing, that bug. I suggest we all stop this show now and we all go to Boots, I am assuming, or just your local pharmacy, and go and demand this test for this worm or fungus.
Because I'm sure if you go and demand testing right now, there's going to be a flood of people who are offering you tests.
This is damn important. If you want to end up like a cockroach in a cave, sealed in by a wasp to be food for its larvae, you go ahead. I'm not taking that chance. Not today. Thank you, Dr. Holding, for talking to us about zombie animals and also about space and movies and stuff, and also some very interesting stuff about cancer and your life as a scientist. Not so much the polymer thing. It didn't land for me. I'd like to, we could workshop this and figure out how that could never come up again. I blanked out at some point. The live stream numbers halved, so that wasn't as good. But you can be found online at Andrew Holding. And I noticed that your name on Twitter, though, now says Dr. Andrew Holding, at least.
Yep.
Good.
I did change that for you.
Yay, peer pressure. I love that. I love it when I get people to change their Twitter stuff. I still think you should change the @, though. At Dr. Holding.
I'm not.
It's got gravitas. I like it. It's never going to go away, isn't it? You can't get undoctored, can you? You're Dr. Holding forever.
If I did something really, really awful, the University of Cambridge would rescind my degree. But I'd have to commit a war crime or something.
Or
to be honest, I don't even know how to do. So that's.
I lack the basic knowledge to commit a war crime.
I mean, it's quite challenging, isn't it, to accidentally commit a war crime?
Yeah. Okay. Well, good.
I'm presuming.
Don't explore that any further.
It's a total word I can't repeat. But but that's not war crime level. That's just you're not a nice person.
Let's hope that your downplaying of the threat of toxoplasma gongai doesn't lead to a lack of your removal of your doctorate. Matt,
do you have a pet cat?
Our friend Sam in the chat room is asking if you're the sort of doctor that deals with itches. He's asking for a friend, he says.
And on that note, follow Matt at MattPT55. Email him, mattpt55@gmail.com. Follow me at Spanners Ready, or the show at Indoors Remain. Still haven't sorted that out. I could do, couldn't I? But who's got the time? What am I going to say? It's at Indoors Remain Pod. I just leave it. At Indoors Remain. Work hard, be kind, have fun, and remain indoors. I hit my little pre-fade button thing again, so I thought the music and everything had